Good morning, everybody. Welcome to the, well, slightly crowded panel. I'm sorry, the stage is not that large, so we're crowding it quite a bit up here. The idea behind this panel is that we are warming up for the day through a discussion about, well, I would say modern web application architectures, efficient web application architectures, just recurring topics at this conference and in this industry. And we have quite a few people up here, so I would suggest for them to introduce themselves quickly, maybe.
I'm Simone Bordet. I work mainly on server-side Java, and I'm really interested in knowing the others' panelists' opinions on modern web applications, because it's a very interesting theme, so that's my take.
I'm Rachel Andrew. I am co-founder of a content management system company. I'm a PHP developer and a front-end developer, and I've been doing this for a very long time, since about '96.
Morning, everyone. My name is Nash. I'm a developer evangelist for Twilio. I'm primarily a Ruby and Rails developer, although also happy talking about JavaScript and things like that. So kind of interesting to see what the Java members of the panel have to say about this.
Okay, my name is Michael Ploed. I'm a principal consultant at InnoQ, and I do a lot of Java software development and also a lot of software architecture consulting.
My name is Agim. I'm also a developer and architect, and I also do quite a lot of Java development, and the last time lately microservices and Spring Cloud and everything about Spring.
Well, I guess I should add that my own background is also in Java land. I'm, some of you might know, but I'm running the Spring Framework open source project for 13 years already, so I have a strong Java background. But I used to be a consultant and trainer, primarily in Java web applications, so I have a multi-year consulting background where architecture always shines through, and even as a framework author, you're constantly facing those questions, right? Which kinds of architectures do people build, even with your own framework? So even from that perspective, I very much care. But here I'm largely the moderator. I might occasionally sneak in an opinion, we'll see. This is also meant to be interactive, so we're going to start with a few prepared questions, but we're going to open it up very quickly for questions that you may throw at the panel or individual panelists. It's up to you. At that point then. Well, we are now in early 2016, and looking back over, say, the past 5 years, right, compared to, say, 2010, I would like to just ask each of you, in which respect have we made progress in terms of web application architectures? What are we doing better now than how we did it 5 or 6 years ago? Could you name a single thing where we have actually made progress on that we're proud of?
Oh, okay, so I'm the protocol guy, so I would say that certainly WebSocket is one good thing, an important thing that happened in this past 5 years. The other thing is a million frameworks, JavaScript frameworks. There's very interesting times in front of us because they're not stopping. They're popping out as we speak. So that's very interesting. I would say that WebSocket, to me, WebSocket was the most important evolution on the web, and yeah, the move to JavaScript front-end development that was really interesting. So.
I think for me, it's a focus on speed right through the stack. And that's been quite interesting, because we're seeing that as the sort of rise of people accessing the web using mobile devices, that's kind of brought that home to those of us in sort of the developed world who are used to having these kind of fast internet connections. And, you know, I mentioned I've been doing this a long time, and when I started, we were kind of talking about this sort of great future where everyone would be on these massive screens and really fast internet connections. And what's actually happened is we're all using these very slow internet connections over Wi-Fi or whatever, and these are tiny devices. And that's made a real big change. I think it's brought this idea of making things fast and performant to everyone. It made it matter to everybody, and that's having huge repercussions, you know, right across the world, which is brilliant.
I can't agree with that. That's amazing. But for me, in terms of like the biggest, I think, thing that has brought us forward in terms of application architecture is the kind of platform as a service things that have come out of the out of everywhere, the kind of Herokus of the world, that kind of thing, where you don't have to worry about your back end too much anymore. You can concentrate on your application, making it fast, sure, but like the kind of the scaling of it in the back end is a lot less to think about. I think that's an absolutely magical kind of thing for what we've got these days.
Okay, totally agree with especially what Phil said regarding scalability and the cloud and so on. What I've seen is a shift away from, especially in Java land, from component-based web frameworks towards request response oriented frameworks. And what I also see is that, and that's I think also a little bit independent, but I think the web has been a major driver of that, is business awareness. I think a lot of businesses are now aware that IT is their key asset, and that enables more, I would say, fast-paced architecture development, software development, releasing with DevOps and stuff like that.
Yeah, I think there was a bigger separation in the last 5 years. So Java is more and more moved to the infrastructure to be a very good REST backend. JavaScript got mature. Things like Webpack and other technologies just came up, which are also very convenient for Java developers when they ask about modularization and everything. So I think every programming language, or Java and JavaScript, they found their role in the last 5 years. So it is nothing in between, a bit of JavaScript in a server-side environment. It is really a separated thing which helps to build cleaner architectures.
Well, thanks. It's actually quite an interesting mix. Since we haven't prepared any answers, just this is pretty improvised. So I'm not aware of what they would have said here. So I'm kind of interested myself to find out. There's actually an immediate follow-up that bothers me, and I guess bothers a lot of people, is have we figured out where to draw the line between, say, web applications, HTML5-based experiences, in particular on mobile devices and tablets, versus what we build a mobile app for? Well, this conference is not a bad example, right? Do you look at the website or do you install the app? Do you mind if every second website that presents a bit of content to you pops up like, would you please install my app? Every time you're accessing it, right? Sort of my own impression is we're kind of still struggling to find out what mobile apps are good for versus a mobile web experience. What's your opinion on this? In particular also, have we kind of developed a better understanding of it, or are we literally still struggling and going to throw it over again next year, right? Where's this going? And
well,
with you,
if I can
don't have
jump
to do it in order.
like there's sometimes a line where the mobile app is the thing you build because the marketing department wanted it, and that's kind of a scary thing. Like I think these things should be built based on the need for the particular features of the platform, and the web has an awful lot of features that we should be able to take advantage of, but people kind of, or sometimes it's kind of easier to fall into the idea that a mobile app is the better idea. Whereas, yeah, but that is then going to take an awful lot more kind of development time, a lot more process. You've got more platforms to deal with, and yeah, I mean, to be honest, I have been using the website. Sorry, John, I've not been using your app, but because it's done what it needed to do for me in this particular case, which is show me what was on next and that kind of thing. So that's kind of where I think it happens. And yeah, if you're going to go native, I think there's got to be a reason for it and a feature that you just cannot have on the web. But
how about connectivity? It's like, to me, I draw the line where I would like to have my content offline. So, for example, I don't have like free roaming here in Austria. So to me it's like, yeah, maybe I don't buy the roaming here because I can install the application, and once I installed it via Wi-Fi, then all the content is there, and I don't need the web anymore. So
then you'll love service workers. But like the application cache has actually been around for a long time, and something in the case of a conference kind of website and that kind of thing is simple enough, I think, to work within the kind of declarative nature of the application cache. Over the last 3 years, the JSConf Europe has always like provided their schedule as a Google Doc. I think they might have like run out of time the first time, but it actually it encouraged people to kind of build a better solution on top of that. And so for the last 3 years, I've hosted like an offline capable version of the conference schedule, which has worked very well for anyone who's used it. But it's a website. It doesn't need any more data once you've got it in the first place, and that's entirely possible. You know, I want to see more of that. Yeah, like data is important, and it feeds into performance as well. Like if you've got all those things cached offline already, you never have to hit the network to find out more, then you're having a better experience that way as well.
Yeah, I think over time we're starting to see, sort of with the HTML5 APIs, we're starting to see, I think, that gap close. And so it's going to be quite interesting, I think, in the future as to, you know, which features actually do benefit from having a native app. And there are definitely things. I mean, we were talking earlier, I'm wearing this Garmin watch, and that links to a really great app, which also links to my other Garmin watch that I use when I'm out running, and all of that data gets linked and synced up, and it uses features of the phone. And that couldn't really be mirrored in a web app in the same way. So there are still things that you think, yeah, you know, an app is definitely the way to go here. But I think I would tend to say, can I do this with web features first? Can I do this with HTML5? Can I do this as a web application and use it on the phone? Or am I hitting up against something that really needs an app, that really needs that kind of development? And that's really where I draw the line, is can I do it or not with the web?
Yeah, although, as you were saying, Phil, sometimes it's somebody requests, you know, a mobile app just for the sake of having it. But let me add a twist to the question. In terms of the communication channels, the efficiency of the communication and of data caching as well, right, between the client, the user front end and backend services, are there any remaining benefits that we can leverage if we build a mobile app versus what we can do in modern browser interaction? Or even the other way around. Are modern browsers advanced enough to have capabilities that are actually hard to replicate in a mobile app, in a native app?
Okay, so I'm not really an expert about mobile development, but I'm kind of assuming that if an app has to communicate with a server, it's probably using HTTP. So on that side, I would say that, yeah, maybe the app could be smarter in making requests to the server, maybe just asking the data, maybe compression, maybe something slightly smarter than a browser. But, you know, more or less it's there. It's, they're on par. So, yeah, I wouldn't say that there is this much difference.
Well, I think it depends on the use case, obviously. A mobile app can store data even more secure, probably, because it can encrypt everything on the device. But on the other side, web pages are pretty crucial if you want to, in a way, enforce that the data is every time up to date. So there's quite often a challenge if you start creating mobile apps for real use cases, medical things and stuff like that. Then you have to think of what is with the data that is on his device, and he's probably not going online the next 3 or 4 times he's using the app. So there are use cases where basically offline storage on the device is not favored because it hinders you to work on that. Then you have to start in your app to make checks and see if I'm allowed to run or do I need to update. So there are sometimes use cases where I really think an offline strategy can be tricky to solve. I'm not saying it's not possible, but tricky.
Mm-hmm.
Yeah, no, I agree with that. That's mad. Like, I mean, I'm kind of thinking like you can actually do that on the web now as well. Like you have all the things in front end, local storage, IndexedDB, service workers in order to be able to store things offline. And some people have done some magical things with that. I saw a talk, actually I keep mentioning JSConf EU. There was a talk there about a team who like built an offline capable, like saving data offline web application, which they were using for data collection in I can't remember the countries now, but where they had the Ebola crisis, they were collecting data on like issues with that, and like they'd be offline for 2-3 days, but when they got back online, it was a much quicker way of dealing with that than the old paper system that they had. So like the web can be quite magical for that. It still works, but you have obviously like whichever way you're going to work with offline data, you have the issue of syncing and getting that data back together. But it can be done either way. It's quite cool. I was going to say something else and I can't remember, so I'll pass it to somebody else.
There'll be another
Just step in there. I think the offline capability and syncing thing, it has to be done either in an app or on the web as well. I think coming back to your original question, do we know where the line is drawn right now? I would say no, we're still figuring out on many ways. And what I also see at a lot of clients I'm consulting is now a shift from the mobile strategy in terms of who initiated mobile strategies in the organization. It was business or marketing departments that said, hey, I need an app. Just for the sake of having an app. So everybody suddenly needed some app, and a lot of them just did like HTML web framing on iOS and Android. And I think customers are now expecting, if they download an app, they want a native experience and not some sort of a compromise. What the web obviously is. You can't have the iOS experience with a web application. And I think the main driver for, if you really build an app, you really have to have a user experience that is similar to the platform you're running on, and not a compromise. And I think this realization is something that strongly emerged throughout the last 2 years or something.
To add a note from my perspective, I care a lot about architectures that are able to evolve and in a timely fashion. And it just occurred to me yesterday, actually, during your keynote, that modern day browsers kind of auto-update themselves anyway and automatically start using HTTP2 if they can negotiate with a web page, whereas a pre-coded client application, programmatically coded, would by default use HTTP 1.1 because that's what the API suggests. That's the case in Java, that's the case in Android as far as I'm aware. I'm pretty sure it's the case in iOS as well, which means the apps need to redo their HTTP access implementation code in order to benefit from HTTP 2, whereas websites running in a browser environment kind of implicitly benefit from browser improvements and browser upgrades. So there's a kind of, which is slightly ironic, right? That the browsers can be ahead of where native applications are. In particular, taking into account that native apps are often coded to a somewhat outdated API level in order for compatibility with back to Android 4 or iOS 7, right? So there's kind of interesting forces at work there where modern day browsers actually shine quite a bit in my respect in terms of what they can do to introduce new features into existing environments.
I mean, that's true, but like the browser's still a runtime, and if you have to update an app to use HTTP2, like on the case of the web, you have to update your server. Like there is, you're not going to automatically get HTTP2 because your server's not going to talk it. So that's difficult. But on the other hand,
but you can update the server, right? So if
you don't have to
touch the client kind of automatically enables itself for HTTP2.
Yeah, and you don't have to wait 2 weeks for Apple to say yes, you can, or something like that. So. It definitely has benefits to the web in that case.
There's also another twist to this, that there's competition among browsers, while there's no competition among Android runtimes. So while you can install Firefox on your mobile phone or Chrome or something different, then of course it's in the interest of these browser vendors to be faster, better, and more up-to-date, and exploiting the latest technologies. So yeah, that's an interesting period we're living in.
Let me open this back up to the audience for a moment. Who's actually working on HTML-based web applications these days? Who's working on native mobile apps? Who's doing both? Okay, yeah, it's kind of what I expected. While we're at it, who would consider themselves primarily rooted in the Java ecosystem? as Java developers, Java architects? Who's doing primarily JavaScript? Okay. Ruby, anyone? All right. Who's kind of, yeah, sure, actually, let's include the searcher. Who's kind of polyglot, switching between languages much at all? Oh, interesting. Okay. All right. You had a question for the audience as well?
I wanted to ask a quick poll about the technology used on the client by you guys. So now let's try to do this chronologically. It's like, okay, so how many of you do mostly, because JavaScript on the client, it's always a little bit there, but mostly server-side generation of the page. I mean by this JSP, PHP, or technology like that. Okay, kind of few, 1/3 more or less. Who's doing, well, then let's move to client-side application using REST, JSON calls, whatever, to the backend to download data and then populate on the client. So in this particular case, who's using jQuery? Okay, kind of 1/3 as well. So who's using Angular, for example? Angular 1? Okay, 1/3. Who's using the modern stuff like web components, Angular 2 or web components? That's the 1, 2, 3, 4. Okay, that's interesting. Okay, okay. So we're not there yet. I have actually very high hopes for web components. I think they are finally the way of getting rid of a bazillion JavaScript frameworks.
You sure?
I'm not sure, but I have high hopes. There's a standard to do things, so yeah, maybe not a bazillion, but you get like a handful among you can choose from. So yeah, I attended an Angular 2 talk at this conference. It was really interesting. So that's you know, again, interesting time ahead.
I thought it was interesting, I think you said earlier, that JavaScript's become mature, and so we have all this stuff on the front end. Like, have the frameworks, has the things we build in JavaScript become mature is like kind of the question for me. And I guess web components, because it's going through this standardization process and because it's getting so much feedback and so much input on it, is kind of an exciting, potentially mature platform for this in the future. I worry about like generating the front end in the front end because it has, I mean, we were talking about performance earlier, and the idea of putting text and images on a screen is very easy when you generate it on a server and put it on a page and that kind of thing. Like, that's the quickest way to get somebody to read your website, and also the most resilient to kind of network conditions and things like that. It's like, that's the one request you need to make in order to get the text of your page onto screen. And so, yeah, I mean, hopefully web components can be a way that we can deal with that, both front and back end as well. I'm not entirely sure on that, but.
So, like, for example, who has a jQuery application and is planning to move away from it to some newer technologies? Okay, so which one? Which one? To Angular. Meteor? Okay. I saw a third one. Yeah. Meteor as well. Okay, interesting.
Sure. Anytime.
Let's assume you have a mission-critical government approaching you, telling you I would like to have a web-based system with an expected life cycle of 15 to 20 years. What would you suggest to architect that process?
Well, I think the honest answer would be COBOL, because it's around for 30 years. So it has proven it has a stable life cycle. But I would approach the customer that it is, in my opinion, not possible. The customer should have, or the government should have a look is, how can I build an architecture that can evolve over the time? But when I look back 15 years ago, we had Internet Explorer 4 or 5. We almost did not have any JavaScript except for adding a CSS class or changing something. So I would rather think, what is a good foundation to start with and to evolve? But I'm pretty sure that in 10 to 15 years there will be, or I think there will be no AngularJS probably anymore, because it's just there will be other approaches that work totally different, that will basically bring frameworks like Angular or other frameworks to a kind of a maintenance mode. So there are very rare frameworks. I think Spring is one exception, Hibernate and others on the backend side who basically have a history of 13 years and more. But I think especially on the web space, it's very likely because they also depend on browsers. So the dependence on Java applications is only the Java runtime. So we see every few years a new Java version with a limited set of new features. But when I see the competition and innovation on the browser space, I could not say to the government, well, I will take Angular and this will stay for 15 years. I would just try to promise him that we will prepare the architecture so that it can evolve over the next years.
I really want to jump in on that because I've been doing this for over 15 years. The thing is, I'd ask them, what is the important stuff you've got here? If it's content, if it's stuff you want to stick around for a long time, then the best way to deal with it is to have it in text. And we've got text-based formats, we've got HTML. So start with something that's going to hang around and then build on top of it. And this is my argument against the whole generating of everything with JavaScript and not actually having something that can generate documents. Because, yeah, those things might go away. We might end up with stuff that we can't read in the future. But I'm pretty sure that in 15 years' time, 20 years' time, you'll be able to load up a web page built using HTML and CSS today, and it will still work. Because the web pages that I built in 96, 97, yeah, they look a bit strange today, you know. They're not what we're building, but they would work and you could read the content. And that's the important thing, is what are we building and what sort of legacy are we leaving behind? Because I think a lot of the stuff being built today is very, very fragile because it's built using things that just might not be around, as we've said, in 2 years' time, never mind 10. Whereas you can be pretty sure that those standard technologies will still work. You'll be able to access the stuff. So it's kind of basing things. I'm really old, I know. And I can bang this drum for hours, right? But seriously, you know, let's create stuff that we can keep and then build the cool stuff on top of that. I love new stuff. And I'm talking about new stuff later today. I love the new stuff. I love playing with stuff. I love this industry. But I also care about what we're leaving behind. And that stuff is still going to work in 20, 100, 200 years' time.
Yeah, it's from just my 2 cents is we need to embrace the evolution of those technologies, right? There is no way we can pretend that we can just freeze a baseline in like right now and keep using exactly that technology baseline for the next 15 years. In terms of decision making, your best bets are in picking something that's kind of where you trust the evolution of that technology arrangement to still be there, or to have a migration path. It doesn't have to be there in its current incarnation, but then kind of there needs to be a sane migration path towards where it's going to be in 5 or 10 years. But there are just no guarantees for anything, right? Nobody knows, in particular in terms of client-side technologies, where this will be in 10 years. But maybe let's use that as an opportunity to revisit the server side for a moment. It's also, these days we're facing challenges, right? We need to implement efficient server architectures that make the best possible use of the given resources available. And at the same time, we need to build maintainable units of deployment, right? So we're kind of facing a lot of challenges, both in development and in operations, but primarily in the way that we design the indirection architecture. So there's a lot of talk about the hype words. It's from the decomposition into microservices, the reactive stream interaction, so the use of threads, the implementation of non-blocking architectures on the server, just expecting a very high frequency of requests coming in that might block waiting on some external resources. I guess some of the trends actually connect. HTTP 2 kind of suggests a very efficient communication architecture at the kind of protocol level, but there might actually be a very high number of requests ending up in the server endpoint architecture, having to be processed in the end in a smart fashion, right? the higher the number of requests from the same client, the less likely it is that you can get away with blocking. So we kind of see a trend towards reactive interaction, but we don't really have the reactive programming models, not properly yet, right? We're in the early stages. We have, well, a little bit of reactiveness in say, well, Node.js, in some of the frameworks, in some of it appearing in Java land, but we're definitely not where we should be in terms of this being mainstream in any shape or form. Most modern day Java web applications are built in a very traditional style still. So what would you, just back to the panel basically, you guys, what would you like to see becoming mainstream in the next few years? What's most important that we kind of wrap our head around it and embrace it, and which part is more hype than actually practically relevant of the things that are just dropped onto the table?
So from my point of view, I agree with you that the asynchronous and easy to use programming model is something that we should definitely look into it and find the right one and make it a standard and available to the Java ecosystem. That's certainly something that is totally needed. Like, I've been on clients that seems like this blocking thing, it's like, yeah, well, what is exactly, I mean, how does it really affect me? It's not really a problem. I mean, I haven't seen it. The fact is that actually server containers or servers in general are very good at hiding these problems, trying to, you know, cope with the blocking aspects of the network communication. But when you actually find an overloaded server or something, most of the time you realize it's a problem caused by high number of threads because all the clients are blocking, because a large number of clients doesn't read properly and stuff like that. So an asynchronous model can certainly help scalability, which means, you know, from my keynote yesterday, it means less money because you can buy a smaller machine on the cloud in order to support the same load. So that's a good thing. And but yeah, the other problem is how do I link this with the application development? And reactive stream is certainly a good solution. I feel that it's still a little bit low level. We need some kind of higher abstraction on top of it, but it's certainly a very good start. It's a brain date simple model that everybody can understand very quickly. It's brilliant in its simplicity. It's going to be included in JDK 9, so it's going to be available like as a standard JDK class. So, and I think the brilliance of this API, it's the reason why it's been included in JDK 9. So it's really simple to use, and so it deserves to be in the JDK. So yeah, again, we are in exciting times because this stuff is yet to be seen. You know, the type-safe guys are working towards that. Pivotal and Spring are working towards that. We as a Jetty team are working towards that. So eventually I'll see a convergence of all these efforts into something that can be very easy to use. So that's my thinking.
What I see, I think, what is definitely going to be established in a couple of years is that asynchronous programming models will be the default in the future. Not these synchronous requests, I send in a request, I wait, I block, and process the request and then return the value. I think in a couple of years from now, we will work nearly exclusively in an asynchronous fashion. What I also see on top of that is that there is a lot of stuff going on in the persistence world. Well, a couple of years ago, we were still going to relational databases as, well, nearly the project default. I think the trend is also going very strongly in terms of more polyglot, event-based persistence models where I have some sort of an event store and some read store which I can highly optimize in order to increase scalability. But what I see around all these, I would say, new trends that are very prominent at conferences right now is what Simone also mentioned, that we're still having, I would say, a very low-level set of frameworks, APIs, and features, and that, especially if you look into like for instance, event-sourced applications, or well, for microservices, there's a lot of stuff going on, but especially some I would say current hype topics, you have to do a lot of stuff on your own. You have to invest heavily in order to build up your own infrastructure for that, based on certain components. And I think there needs to be a higher abstraction and some abstraction frameworks on top of that. I'm not going to say that we need some microservice suite by a big vendor or something like that, but we need more abstraction. I think if you look at Spring Cloud, for instance, or the stuff that Netflix is releasing recently, this helps tremendously in terms of the adoption. And I think that is something where the community has to come up with higher levels of abstraction as well.
Yeah, just to add, I think also, I mean, one thing is the developer, the other thing is also, yeah, the frameworks must adapt, because over the last year, the only thing that was stable is this kind of synchronous single threading model. So it's everything around security, transaction management, etc. So I think the experience for the programmer must get better in the next years, because they will only adapt asynchronous programming if it really brings benefits and does not have very much drawbacks. And that is also something where it must be an evolutionary step. I don't think that if you have questionable benefits from the asynchronous programming for your use case, that you should switch and have something that doesn't work anymore, because everything is aligned with this single threading synchronous model in the development.
So I have a question for the audience. How many of you think, or what are these guys talking about? Blocking stuff? Okay. So how many of you would actually love to go to an asynchronous model and having a programming model which is asynchronous? All right, most of the audience. Okay, cool. So we're on the same page. We're on the same page. So for those that raise the hand, well, what is this blocking thing that these guys are talking about? So have you ever had the problem where you have a JDBC connection pool going to the database, and then suddenly the connection pool gets exhausted and you have no more connections to the pool? Okay, so that's the main blocking problem. You have 10 connections to the database, you send 10 queries to the database takes 20 minutes for each one because someone has forgotten an index in there, and then the 11th request to the database cannot even go to the database because you have the 10 connections closed in there, right? They're blocking, waiting for a result. So that's the problem, and if you move this problem from the interaction between the server and the database, and you move that to the front end between the browser clients, the internet, and your server, then you realize that the problem now scales to numbers that are incredible, because you can have, like, imagine CNN.com, I mean, it has millions of people connected to their servers. So this problem in that particular place, in the front end, in the connection between the clients and the server, then that becomes a really big problem. That's why you need, for example, if you want to cope with this, you need enormous servers, enormous amount of resources on the server. On the other hand, if you go asynchronous, you don't need these big giant servers because you can actually be much, much more efficient. So that's the context for those that didn't know. So what about the Ruby world?
We've got some asynchronous stuff. I don't know. It's not no, I mean, Ruby doesn't have too much in the way of asynchronous stuff. If the stuff that is there is bolted on, I'd like to point out, I managed to miss the question on governments, but the UK government, I think, started with Ruby on Rails in their recent award-winning site, so that's kind of a nice thing. Yeah, it's not particularly asynchronous. Well, there's a lot of Ruby developers right now kind of looking outwards from Ruby to see what else they can kind of work with. And kind of what's exciting a lot of people is Elixir as a language, which is, I don't know if anybody's heard of Elixir much at all, but it compiles down to the Erlang virtual machine, and so is highly concurrent, highly kind of asynchronous and mad. I mean, like, if you want to talk about the abilities of Erlang to scale, I think WhatsApp has a 50 or so engineering size team and just passed 1 billion users and 42 billion messages a day. So it's kind of but Erlang's horrible. I don't know if you've looked at Erlang. I can't read it. I just can't look at it. But Elixir has that kind of the ideals of like Ruby as a very readable and very usable language, but the asynchronous and very lightweight process-based nature of Erlang, and I think that's kind of exciting, and is exciting the Ruby community quite a lot at the moment.
Yeah, I think the Ruby ecosystem has such a nicer, good-looking APIs. That all the blocking part is actually hidden. You don't see it. Like, for example, if you have an active record and you do find all, or what's the name of the method, well, that's blocking, but you don't see it because it's so nice. I mean, it's just find all, done. You don't have this whole try catch that we have to do in Java with JDBC. It's all the crap. Don't do that.
We probably should try and catch more things, but that is true. It does. Like we do have abstractions for everything. I mean, I'm kind of worried because we're about to hit Rails 5 at some point soon, and that comes with a built-in kind of built-in WebSockets as well, the Action Cable library, and that is something that's going to like start to take up connections on a server that's powered by Ruby, and that's not something that it deals with very well. The more connections is just going to keep it busy because they are mainly synchronous. So I'm not entirely like there is the concurrency work that's been done by the core team there, and in fact other contributors who've done a lot of other kind of concurrency in the Ruby world has been quite magical, but I'm still scared of it. So yeah, that's why I've been looking out to other things, certainly.
So asking the audience, say with a 2-year horizon, which pain point in modern web application development would you like to be addressed? Where would you like the infrastructure providers to focus on in the next 2 years? Is there anything where you just, every time you're touching it, you feel like, shouting at somebody?
Like if you have the Spring lead and you could ask him something, what would you ask?
Well, you've also got an HTTP server vendor rep here, basically, with in-depth understanding of the challenges of implementing it. Basically, do you have any wishes that you'd like to be addressed seriously? I mean, realistically addressed, right? I mean, from the perspective of you guys, is this, do you see this actually becoming, well, more mainstream than it is now?
Can you please repeat the question?
Yeah, sure. Yeah. So, correct me if I'm wrong, but you would like to see something homogeneous between client and server so that you can actually develop using the same technologies on the client and on the server. That's use the same rendering code on the client and on the server.
Yeah, that's That's quite interesting. I think that the idea of greater cohesion between the front and the back end would be fantastic. Far too, like we have Angular, Ember, React, all these kind of things which are working off over there, and we have other server sides who are working over here, and they don't really talk to each other. I mean, Ember talks to Rails a bit, I think, but even so, it's not obvious, the connections normally, and so a greater cohesion. But then you have something like Meteor, which seems to take over everything, and you don't really have much control anymore. And that again, that scares me, and it doesn't seem like it's a progressive enhancement on like serving up the HTML and then working on top of that. And I really like that idea. I'd like to see that, the ability, to have the front and back end just work better together, and not have to mess about with it yourself.
Yeah, there have been efforts in the past. The last one that I remember was GWT in Vaadin, but yeah, they didn't really took off. I don't know.
Yeah, Vaadin somewhat popular in certain parts of the industry, but I'd kind of like to challenge the question: is that actually a necessity? Do we have to have that homogeneity between the client and server implementation languages?
Yeah, I'm not convinced that we do. I think it's nice if we can get things that both, I mean, I work across the stack, so I do back-end development in PHP and I do front-end development in CSS and JavaScript. And I would tend to work in a progressively enhanced way. So we build HTML pages and then we use JavaScript to do things with them and make them look cool, but they still work if you don't have JavaScript or JavaScript doesn't load or whatever, or in 15 years' time. So I guess what I'd like to see, maybe it's not the same language, but maybe it's being able to actually speak as a team the same language about this stuff. So we don't have this situation where you have back-end developers generating some awful HTML and saying, here you go, front-end developers, play with that and do your cool stuff with it, make it look nice. So I think sometimes it's about that process. It's about having, for instance, templating languages perhaps that can work at both sides. You know, you can have a templating language which is really cool that you can generate with PHP or with Ruby or with Java or whatever. You end up with HTML and then you can progressively enhance that HTML. And maybe it's thinking about things like that and getting together in the way that kind of the DevOps world has brought together the ops stuff and the developers, and really cool stuff's coming out of that. Can we get more of the front and back end developers working together and coming up with ways to template this stuff and generate this stuff so we can actually progressively enhance without everybody having to learn multiple languages and multiple ways of working?
I think, I also think that these highly integrated technologies, we're kind of moving away from that we all on every place try to do the same, that we highly couple the front end and the back end together on a technology side. I think it's going more in a way that we have some lightweight protocols between the two, but that doesn't mean that we will have two separate teams. What I really like, highly like in this, especially in this microservice environment, in these discussions, is the idea of self-contained systems, where we have one team delivering the front and the back end together as a team, and this is cut into, I would say, we could use domain-driven design speak, bounded contexts, or functional verticals, and they deliver one feature front to back with the technologies that they like. But that doesn't mean that it has to be highly coupled, highly fixed and glued together on a technology side.
Yeah, I think even though there are advantages to have a unified model, I think there are also a lot of disadvantages because you make a kind of a compromise between both. One good example is, or the question first, who is using JSF still?
And who dares admitting it, right?
Okay. I think, for instance, JSF was a pretty good example where a standard tried to abstract away HTTP and browsers. It's like you have an event listener, even though it runs on the server. Yeah, there is some network in between, but you should not take care. It's a bit of an event-driven programming model on the server side. Even the interaction happens on the client. So I'm very careful if it goes to unification of something, even though it likely might be higher productivity, but it leads to things like, bad HTML, which is just generated from some framework. and not to a very good app experience.
Let me just hang in there. I've been doing a lot of projects and consulting in the area of component-based web frameworks, especially Wikit, some JSF, and so on. And what I've seen over the years in every project is that the team started off with a very high productivity, everybody was happy, but after, let's say, 2 to 4 sprints, we started to see, oh, we need a workaround for some HTTP stuff here, we need a workaround there, we need a workaround here. And so if you look at projects adopting these strongly component-based, highly integrated technologies, you will, one common thing that I've always seen is there is a high number of workarounds for the web because you don't have HTTP and the idea of HTTP, which is the base of the web, in your hands anymore. So I think a lesson learned is that the component-based model for web applications is a very tough compromise to swallow.
Oh, that's interesting. So you just ruined all my high hopes for web components. But
I mean, server-side.
Sure. But I turn the question around. How about web component style brought to the web servers, to the server side? Could that work?
I'm not sure. To be honest, I haven't taken a deep look into the web component stuff, so I really can't judge that right now. But based on the experience, I've been, let's say, highly motivating towards component-based Java server-side web frameworks over the couple of years. But in the recent years, I kind of moved away from that because I said it's better, especially if you work in the public web sector where search engine optimization and stuff like that gets more important than ever, SEO, SEM, and all that stuff. You're better off having a lower level of abstraction in your hands on these kinds of things.
Yeah, just wanted to add very quickly. I think it's every time cautious if people try to do something easy and they just ignore things like network, for instance. It's not only the web frameworks, it's everywhere. It's also microservices everywhere in our domain. And I think everything that happens between backend and the client should every time not forget that they are running on HTTP, probably HTTP 2. They are running, the state must be very clearly in some place and not in 2 places. And if you try to abstract that away, so I don't care about state, I don't care about HTTP, then you're likely hitting problems which end up in workarounds then.
Yet, I have a counter-argument. Yesterday, I attended a very interesting session on web performance, and I was stunned to see the N+ select problem that we typically have with Hibernate and JPA and ORM system, having that on the web with microservices. So you're basically, from your web client, you're saying, okay, I need the list of customers. So you make one request, get the list of customers down, and then you make a bazillion requests, each for one of each customers over the web. So maybe having HTTP at your hands, that's not something, yeah, I think it could be dangerous, right?
Well, I think this is a valid argument, but even for that, there are ways to solve that. I mean, also companies like Netflix, they do API gateways, or they have Falcor as a data technology.
Yeah, they know what they're doing.
That, but still they do acknowledge that I have HTTP and I query the server, and the server is stateless in a way for me. So I might have a security token or session somewhere, and these are the things where I feel that component frameworks just fall short in the past.
I guess we'll have to wrap up. It's already past 10. Thanks for your participation on the panel, for the lively interaction. There's plenty of opportunity to talk to those guys. There are, most of you are actually speaking today, or it's at least a little bit around still, so feel free to approach them and extend the conversations. Thanks for your attention. Enjoy the coffee break.